Well, so in the last class, we have started discussion on Deuteron problem. Okay, so we have seen that properties of Deuteron. Okay, so today we will solve that whole Deuteron problem. Okay, so there are many experiments have been performed to formulate that nuclear potential of Deuteron. Okay, but why we are interested about Deuteron? First of all, you need to understand that also, because Deuteron is the simplest case in which there is nuclear force exist. Okay, okay, if you have a one nucleon, then nuclear force cannot exist. Okay, you have a two nucleon in which there is nuclear force exist, but that is possible only if neutron, because neutron system or proton system, that is not exist. Only two nucleon system, that is deuteron, that is exist in nature. Okay, in which there is a nuclear force exists. That's why we are interested to study the Deuteron problem, because it's the simplest case in which there's a nuclear force exists. So there are many experiments have been performed to formulate that nuclear potential exists inside that Deuteron, but that result was so much complicated. We cannot write the potential form of Deuteron. Okay, that was actually puzzling for nuclear scientists, that obtained result from experiment were so much complicated. We cannot write that potential form of Deuteron. Then what we can do? We can take some simplified form of potential. Okay, then we'll use this potential to solve that Schrodinger wave equation, and we'll find that strength of nuclear potential. Okay, so that assume potential in inside Deuteron, that is V of r equals to minus d naught when r is less than r naught. Okay, and is actually 0 when r is greater than r naught. Okay, so why I am taking that simplified potential, and that is also you should understand why I am taking simplified potential. Whenever you are going to do research, you have to build up model to solve some Schrodinger wave equation to get energy eigenvalues and other parameter. So your potential should be, or whatever parameter you are taking, that should be simplified to handle that whole model. If you are taking complicated potential, then you cannot handle it. It's very difficult to handle, or it's very difficult to solve. So you have to take that potential that should be simplified, but that can explain that all properties. Okay, that's the main thing that you have to apply in research field also. Whenever you are building some model to formulate or to get some properties, that model should be simplified, but it should explain that properties that we are going to study. Okay, so that is the potential. They have assumed this is the centralized potential. Why this is a centralized potential? How we'll understand? Because you can see that potential is actually depends upon position, only depends upon r. That's why it is called centralized potential. And what is r naught? R naught is the range of nuclear force. So if I draw this potential, it will be like this. So this side you have a distance between neutron and proton inside Deuteron, and along y-axis you have a v of r. So if we plot it, that nature of curve will be like this. How it will look like? And this strength is actually V naught with minus sign. And here you have this position. This is your R equals to R naught. R naught is the range in which there is a nuclear force exists between neutron and proton inside neutron. And these values is actually known from experimental data. That is 2.1 femtometer. Okay. So obviously, when that nuclear force exists within this range, okay, and beyond this range, nuclear force is zero. So obviously, potential will also be zero, because potential actually related to force. Okay, so this is the distance, or this is the range in which there is a nuclear force exists between neutron and proton inside neutron. Okay, and this is the assumed centralized potential. Again, I'm saying this is the assumed potential, and that is simplified, because if you know when you have a square wave potential, then it is very easy to handle. Okay, I'm taking this is a centralized potential, but I'm not saying that nuclear force is actually central force. You are assuming potential is centralized, but nuclear force is not central force. Okay. Now, if you write the Schrodinger wave equation, so what is our goal? Our goal is to calculate that strength of potential. This is the barrier height, right? How much is the strength of this potential? That is our goal to study. Okay. Now, if you write the Schrodinger wave equation, H psi equals to E psi, right? And when you have a centralized potential, then this wave function psi has three components, right? R, theta, and phi. Whenever you have a centralized potential, then you can easily separate that R component, theta component, and phi component by using separation of variables that you have learned in hydrogen atom problem. And if you remember that energy eigenvalues actually depends upon R component of the wave function, right? So the reason behind taking these centralized potentials is also, if you are taking centralized potential, then what will happen? You can easily separate that R component, theta component, and phi component of your wave function. Okay, and your energy eigenvalues will be depends upon R component of the wave function. Now we'll have a Hamiltonian here, right? This Hamiltonian will have two components, if you remember, right? It will be like minus h cross square by twice mu del square, and then you have a v into psi equals to E of psi. Why I'm taking mu here? This is also interesting. I'm taking that reduced mass of your systems. If you have a Deuteron system, then reduced mass will be how much? It will be mp into mn divided by mp plus mn. Here I'm taking a reduced mass, and also you know that mass of a neutron is almost close to mass of a proton. We substitute it, you'll get reduced mass, that will be mpy2. But why I'm taking reduced mass? This is interesting actually, because this is a two-body problem. How will understand two-body problem? Suppose this is the coordinate system, okay, and suppose this is the position of proton and this is the position of neutron. This is your Deuteron system, right? And let us define that position of proton from the origin, that is position vector, right? This is r1, and for neutron it is r2. Now, if you are measuring the distance of a neutron from proton, r will be how much? Kitna aa jayega r? How much you'll get that r? That will be r2 minus r1, right? So this is the coordinate system, this is the Deuteron system, right? The position of a neutron from that origin, that is R2, and position vector of proton is R1. Now the position of neutron with respect to proton, that is R equals to R2 minus R1, right? Now you see that interesting thing here. You are measuring the distance of a neutron with respect to proton, and that is R equals to R2 minus R1. So you have to sit in the frame of proton, right? You have to sit in the frame of proton, and you have to measure the distance of a neutron, right? Or you have to find the position of a neutron. Now interesting thing is here that proton is not at rest. Why? Because it is experiencing nuclear force, right? Inside nucleus, every nucleon is actually experiencing nuclear force. So it is actually under acceleration, and you are sitting here and you are finding that position of neutron that is also moving, right? That is also moving because of nuclear force. Whenever you have a nuclear force, it means there is an acceleration. So actually, interesting thing or main thing is that you are sitting here in the inertial frame, sorry, non-inertial frame, because that frame is actually accelerating. And you know, when you have an accelerating frame, that is called non-inertial frame. That is called non-inertial frame. So whenever you have a non-inertial frame and you are trying to solve that problem, or you are going to apply that Schrodinger wave equation or Newtonian mechanics, then what you have to do, you have to convert that non-inertial frame into inertial frame. How will convert that non-inertial frame into inertial frame? Just what you have to do, you have to replace that mass of this body by reduced mass of the system. What is the meaning of this? When you are replacing that mass of this neutron by reduced mass of the system, it means somehow you are fixing that position of proton. Now your non-inertial frame is actually converting to inertial frame. So whenever you have a non-inertial frame, what you have to do, you have to convert that mass of this body into reduced mass. Then what you are doing, you are actually converting that non-inertial frame into inertial frame, and that you have to do, or you should do that to solve that Newtonian, to apply that Newtonian mechanics, or to solve that Schrodinger wave equation. Okay. Well, so now what I'll do, you have a psi that will have three components, right? R, theta, and phi. And I'll write that we'll have a phi of R into oi lm, theta, and phi. Right? The R component and this is the theta phi component. You know this, right? Spherical harmonics. Now again, if you assume that phi of R that equals to E of R, some function of R divided by R. Now if you substitute this equals to this, and if you put this wave function in Schrodinger wave equation, and if you separate that R component, theta component, and phi component, then your R component will becomes like this. So what I'm doing, this is your total wave function. So total wave function you can insert in your Schrodinger wave equation. Then by using the method of separation of variable, you can actually separate that R component of the wave equation, theta component, and phi component. After doing this, if you substitute that R component equals to some function divided by R, then your wave equation will be reducing to like this. We'll have h cross square divided by twice mu. Okay, and then you will have del square u of R by d R square. And then you have V of R, and there will be something here. Can anyone tell me? यहाँ पे क्या आ जाएगा? Sorry.
The centrifugal potential.
There will be some central part, right? You know, centrifugal part, of course. L into L plus 1 H cross square divided by twice mu R square, right? And then we'll have E of R equals to E of R. ठीक है? And for ground state, this is actually some positive number, right? That L can take values. क्या क्या L का value possible है? That will be like 0, 1, 2, 3, and so on. Right? So this term will give some positive number. Okay. And for ground state, for the ground state of Deuteron, what is the possible value of L? That should be 0, right? We are looking at the ground state of Deuteron system. In fact, there is only one state exists in Deuteron. So this is your potential, and this will be the state exists inside Deuteron. And that will be, this energy will be how much? Kitna hai? That will be 2.22 electron volt. MEV, right? So this term is some positive number. You are looking at the ground state of Deuteron. So for ground state, that energy should be minimum, and that is possible when you will have minimum value of this. And minimum value of this means L is 0. In fact, there is only one state exists in a Deuteron, and that is the ground state. So now if you substitute that L equals to 0, then your equation will reduce to H cross square divided by twice mu del square U by del R square plus V of R E of R equals to E of R. Right? Is this clear? Well, so now what we'll do, I'll use that potential form for two reasons, right? There is actually two reasons. I forgot to mention that. Please mention it. So we'll have two reasons, right? So this is your reason 1, and this is your reason 2. Okay. In reason 1, it means R less than R naught. Then V of R is how much? That is your minus V naught. Now if you substitute it here, your equation will become minus H cross square by twice mu del square U by dr square plus minus that will be minus of V naught U of R equals to E U of R. And I'll take this is your equation number 1. Okay. Okay. Now if you bring this term on the right hand side, okay, if you bring this term on the right hand side, then it will be E plus V naught. And if you bring this term, this factor on the right hand side, then it will be like del square U by dr square. That will be equal to how much? Kitna jayega? That will be plus. So you will have E plus V naught into u of r, और यहाँ पे क्या आ जाएगा, that will be minus twice mu by h cross square, right? Is this clear? We bring this term first, this side it will be e plus v naught, you will have u of r, and on the left hand side you have a minus h cross square by twice mu. If you multiply it by minus 2 mu by h cross square both sides, then this will be plus 1, and this side on the right hand side this factor will come, right? And this will be equals to minus k square u of r. But why I have taken, so if you see that k I have taken like root over twice mu by h cross square, then e plus v naught. I have taken k like this. Why I have taken k like this? Because that k is actually representing, k is your propagation vector, right? K is your propagation vector. If you remember in quantum mechanics, you have learned many times that k, whatever you are assuming in the wave function, like exponential sum something into x, so that something is actually propagation vector, and propagation vector will always be some positive number that should be real. Propagation vector cannot be like complex number. So propagation vectors should be some real number. In that आपको ये propagation vector को positive number choose करनी है. Now see, this number is actually positive. ठीक है, तो आपको प्रोपागेशन वेक्टर को क्या करना, दैट प्रोपागेशन वेक्टर शुड बी सम रियल, नॉट पॉजिटिव, दैट शुड बी सम रियल नंबर. So I've taken this factor in such a way that it will be positive. Why? Because you see that e is actually negative. E is actually negative with some value that is minus 2.2. Now you see that v naught minus v naught is actually higher than actually e. So v naught is actually v naught is positive number, and that is actually higher than minus 2.2. So as a result, this will be your positive number. This is already positive number. So as a result, आपका कोई positive number का square root लोगे तो obviously that will be some real quantity. So आपको ये जो factor है, you have to choose in such a way that this should be some real, because at the end this represent that propagation vector, and that should be real. So you have a differential equation like del square u equals to minus k square u of r. So what is the solution of this equation? क्या आ जाएगा solution? u of r equals to a sine of kr plus b cosine of kr. And I'll take, this is your equation number 2. तो आपको जो प्रोपगेशन वेक्टर है, आपको ऑलवेज दैट यू हैव टू चूज लाइक रियल नंबर, है ना? आपको फैक्टर इस वे में चूज करना पड़ेगा, एंड रीजन आई ऑलरेडी टोल्ड यू. So this is your equation number 1, this is your equation number 2. Now if I write that Schrodinger wave equation in region 2, in region 2 where r is greater than r naught. So in this region I can see that potential is actually v of r is equals to 0. It means your equation will be minus h cross square by twice mu del square u by dr square u of r, and that will be equals to e u of r. That will be equals to e u of r, right? So again, if you bring this factor on the right hand side, it will be minus, sorry, that will be del square u by dr square equals to minus twice mu by h cross square e u of r. And that will be equals to gamma square u of r, where gamma is how much? Gamma will be minus twice mu by h cross square e. ठीक है ना? बट मैंने कैसे गामा को यूज किया? अगेन दिस गामा इज योर propagation vector that basically represent the direction of propagation, and direction of propagation cannot be some complex or imaginary number. Direction of propagation will be some real number. I have taken this gamma here in this differential equation. Gamma is representing that direction of propagation. Again, gamma should be positive number, right? And I have to take gamma like square root of minus twice mu by h cross square, then e. ठीक है? क्यों मैंने इस way माइनस यहाँ पे लिखा? Why I have taken minus here? If you remember in the previous case, when I have taken k, that was like some square root of some positive number, because inside square root that was already positive. But यहाँ पे देखो, this e is actually ये e जो है, this is actually some negative number. So this negative into negative, that will make positive number, and square root of positive, that will give you some real number. So you have to take that propagation vector in such a way that it should be real number. Okay. Now what is the solution of this equation? You have an equation like del square u by dr square equals to gamma square u of r. What is the solution of this equation? The solution of this differential equation will be u of r equals to c exponential gamma r. C exponential, let us take some different number, beta r plus d exponential minus beta. Already I have assumed, right, gamma. I cannot change it. It will be gamma, then you have r, then you have a d exponential minus gamma, and then you have a r. Okay, and I'll use, this is your equation number 3. Okay. Now we'll use that boundary condition. So if you remember that you have a phi of r, that was u of r divided by r, right? U of r divided by r. It means u of r, that will be r into phi of r. ठीक है ना? It means at r equals to 0, what will the value of u at r equals to 0? कितना value आएगा इसका? So you have a function like this, u of r into r. You have a r equals to r into phi of r. So at r equals to 0, u of r should be 0. U of r should be 0, and you have a u of r equation, right? A sin kr plus b sin cosine r. So that will be like a sin kr means a sin of 0 plus b cosine of 0. Okay, a sin 0 means that will be 0 plus b, and that should be equal to 0. It means b equals to 0. ठीक है ना? यहाँ से क्या पता चल रहा है? That b should be equal to 0. Now your e of r become a sin of kr when r is less than, or I'll use, this is your equation number 4, and that is when r is less than r naught. When r is less than r naught, then that radial part of your wave function will be a sin of kr. Okay, and you have a, this is the radial part when r is greater than r naught, right? And you know that wave function should be vanishes at r tends to infinity, right? At r tends to infinity, that wave function should be vanishes. So it means this wave function will be 0 at r tends to infinity, right? So it will do u of r tends to infinity, that this term c exponential infinity plus d exponential minus infinity, that will be equals to 0, because wave function should be vanishes at r tends to infinity, and this term already is 0, right? D into exponential minus infinity, this term 0. Okay, and you have a c exponential infinity, that is equals to 0. What is the meaning of this? This term is non-zero, right? Exponential infinity means some infinity. So this term is non-zero, obviously c will be 0. Obviously c will be 0. Now, if you substitute that c equals to 0 in this equation, then u of r will become how much? That will be d exponential minus gamma r. Okay, and this will be your equation number 5 when r is greater than r naught. Okay, so you got that expression for u of r, okay, radial part, in two different region, right? So in that region on, that will be a sine of kr, that we have obtained from boundary condition. Okay, and also u of r in the region 2. Okay, that is this. Okay, again, that you know that property of wave function, that wave function should be continuous everywhere, right? It should be continuous everywhere. It means that wave function should be continuous at r equals to r naught also. Now if we apply this, that wave function is continuous at r equals to r naught, if we apply, it means a sine k r naught, that should be equals to d exponential minus gamma r naught. Because why? Because wave function is continuous. What I can write, that a sine of k r naught, that should be equals to d exponential minus gamma r naught, right? And I'll use, this is your equation number, I'll take that equation as equation number 6. Again, that first derivative of wave function should be continuous everywhere, right? It means that first derivative of wave function will also be continuous at r equals to r naught. So what I'll say, what I can say, that d by dr a sine of kr at r equals to r naught, that will be equals to d by dr d exponential minus gamma r. Okay, one will be gamma, one will be r. Okay, at r equals to r naught, right? It means here how much you will get? You will get a k cosine of k r naught, right? And that will be equals to minus gamma d exponential minus gamma r naught. Just I have differentiated and have substituted that r equals to r naught, because I am looking that continuous wave function at r equals to r naught. Okay, so this will be your equation number 7. So I have applied that properties of wave function. It should be vanishes. It should be vanishes at infinity, and that first derivative, sorry, it should be continuous everywhere, and first derivative will be continuous everywhere, right? Now if I divide equation 7 by 6, if I divide equation 7 by 6, then on the left hand side you will have This A will be cancelled and you will get K cot K R naught. That should be equal to how much? On the right hand side, this factor will be gone. This factor will be gone, only will get minus gamma. Right? Now, if you multiply both sides by R naught, so you'll get K R naught equals to cot of K R naught minus gamma of R naught. And I'll bring that minus this side. I'll bring that minus this side. So it means what I can say, I can write, I'll just substitute that value expression for gamma and K. If I substitute it, I'll basically get square root of minus twice mu by h cross square, right? Twice mu by h cross square, then you have a E R naught, and that should be equals to minus square root of twice mu by h cross square, and then you have a E plus V naught R naught outside of square root, and then we'll have a cot of square root twice mu by h cross square, and then you have a E plus V naught, and then you have a R naught that is outside of square root, right? And this is your cot. It means it is look like some eta equals to minus epsilon cot of epsilon. Now see the interesting thing here. This equation. If you see this equation, you know the reduced mass of a system, MP by 2. Energy values that is known, that is minus 2.2 MeV. R naught, that is also known. That is what? R naught is some, that is range, that is 2.1 femtometer. Okay. So you have a single equation. I can see everything known, only unknown parameter, that is V naught. You have a single equation and there's only on unknown quantity, that is V naught. So you can solve this equation by using mathematical model or some mathematical tool like Mathematica. Okay. I mean, you cannot as a some complicated form. This is your actually this is a single equation on unknown quantity, but the form of this equation is not actually quite simple. It's actually complicated. So you can use mathematical tool, for example, Mathematica, to solve this equation. If you substitute that values of all parameters, you will get that value of V naught. Okay, and that obtained value of V naught is actually 36 mega electron volt. Okay, so if you insert this equation, if you use that mathematical tools to solve this equation, if you substitute all that properties, you will get that strength of potential, that is 36 mega electron volt. Can you imagine that when you have a two nucleon system, that depth of the potential that is 36 mega electron volt. Mega electron volt, can you imagine? So you can think like your nucleons inside nucleus, okay, experiencing some infinite potential well. Why that? Why? Because that you can see that strength of potential is not actually simple number, it's a big number, 36 mega electron volt when you have it only two nucleon system. Okay, so in the interview also they may ask that, can you tell me that example of infinite square well system. Okay, why that is infinite square well system you learn in that quantum mechanics. So one of the example that you can give, that nucleons inside nucleus, they are actually experiencing some huge amount of potential, and that you can think like a infinite potential because of this large number. Okay. Now this kind of this kind of equation you have solved in quantum mechanics, right? कैसे आप लोगों ने solve किए हो इस तरह की equation को? How you have solved this?
Sir, that graph between eta and the
Exactly. So by using graphical method, you can solve this equation, right? If you solve this equation, so you have two axes. One is your epsilon, another is your eta. Okay. Now if you plot this curve minus epsilon cot of epsilon, so that plot will start from here, from pi by 2. So it will be like this. And this is your minus epsilon cot of epsilon, right? And you have a eta square plus epsilon square, है ना? ये कितना आ जाएगा? So you understood what is eta, right? Eta क्या है आपका? ये वाला factor with r naught. This is your eta and this is the epsilon part. So we substitute here, you will get that value of eta square plus epsilon square, and that will be कितना आ जाएगा? That will be twice mu by h cross square v naught, and then you will have a r naught का square. You can, है ना? ये कर लोगे ना? This is your eta, right? With r naught. K with r naught, that is actually eta, and gamma with r naught, that is your, है ना? K with r naught, that is your epsilon, and gamma with r naught, that is your eta. So eta square plus r square, just you substitute these values, you will get twice mu by h cross square v naught r naught square. So this is the equation of circle. If you draw that circle, so the intersection point of this circle with this graph will give you that energy eigenvalues. Okay. And this is the radius of your circle. So to get that energy eigenvalues, what will the minimum radius of this? What will the minimum radius of this curve? ये radius कितना होनी चाहिए minimum? Exactly, it should be greater than equals to pi by 2, right? So you have a graphical method, you are drawing this, and this is the circle, right? Eta epsilon plane में आपका circle है, so the intersection point will give you that energy eigenvalues, है ना? So for this intersection, that radius of your circle should be how much? That should be greater than equals to pi by 2, right? So what I can say that क्या कह सकते हैं हम कि स्क्वायर रूट ऑफ eta स्क्वायर प्लस एप्सिलॉन स्क्वायर ये कितना होना चाहिए? दैट शुड बी ग्रेटर देन इक्वल्स टू pi by 2, राइट? है ना? बिकॉज एट द एंड दिस इज द रेडियस, है ना? स्क्वायर रूट ऑफ eta स्क्वायर प्लस एप्सिलॉन स्क्वायर, दैट इज योर रेडियस. इट मींस eta square plus epsilon square, that will be greater than equals to pi square by 4. ठीक है ना? Now if you substitute that value of eta square plus epsilon square that we have calculated, if you substitute it, so you'll have twice mu by h cross square, and then you have v naught r naught का square, that should be equals to greater than equals to pi square by 4, है ना? और mu का जो वैल्यू होती है कितना होती है? mp by 2, so it means it will be simply mp, because 2 mu is nothing but mass of a proton. क्यों? क्योंकि mu की वैल्यू आपने कैलकुलेट की हो, that is mp by 2. It means that v naught should be equals greater than equals to कितना होना चाहिए? pi square h cross square divided by for mass of a proton into r naught chi square. So this will be the strength of potential. Okay, so this kind of based on this equation you may get a question in next in the upcoming examination. Okay, ठीक है ना? If you have question you can ask me on that, otherwise I'll go to that next part or next topic. Do you have any question on that?
So what type of the question would come from the section?
They may give you this parameter. Okay, suppose they may provide that range. They may change that range and they may ask will be the what will be the strength of the potential. Okay, or this will be the main parameter, right? V naught and R naught square, how they are related.
Okay, sir.
You get that strength of the potential, how it is depending upon range.
Okay.
Based on this, they may provide this and they may ask what will be the minimum value of strength of the potential. They may provide this and they may ask that range of that potential, range of that nuclear force, like this.
Okay.
You understood that problem? I mean, whole calculation. Did you get everyone? How we have obtained that? Everyone understood that?
Yes, sir.
Now you have a nuclear reaction. So suppose you have a nuclei is interacting with B nuclei. Okay, A nucleus is interacting with B nucleus and they are producing C and D nucleus. And suppose the nuclear mass of A nucleus is Ma, for B it is Mb, and for C nucleus it is Mc, for D nucleus it is Md. Okay, this is the nuclear mass of A, B, C, D. Okay, and let us assume that kinetic energy of A nucleus is Ka, for B it is Kb, and for C it is Kc, for D nucleus it is Kd. Now, for any nuclear reaction or decay, that energy should be conserved, right? Energy should be conserved. It means the total energy of the reactant should be equal to total energy of product. ठीक है? Total energy reactant का कितना होगा? So total energy means total energy of A plus total energy of B. So total energy of A will have two components. One will be kinetic energy, another will be rest mass energy. So if I apply that conservation of energy, what I can write that Ma C square plus K, that is the total energy of A nucleus. Then you have a Mb C square plus Kb. That should be equals to Mc C square plus Kc plus Md C square plus Kd. This is arising from conservation of energy. That energy should be conserved for any decay or any reaction. Now, if I bring that rest mass term on side and kinetic energy term other side, so what I can write, so you'll have Ma plus Mb minus Mc minus Md into C square, that will be equals to Kc plus Kd minus Ka minus Kb, and this is defined as Q value. Okay, so Q value is nothing but that kinetic energy of the product minus reactant or rest mass energy of the reactant minus product. Okay, ठीक है ना? Test mass energy of the reactant minus product. And there are basically two different cases. On if Q is greater than 0, what is called this process? Q0 greater than 0, that process is called what? क्या बोलते हैं इसको? That is called exothermic process, and that process is actually spontaneous. This is called exothermic process. That is called exothermic process. What is the meaning of exothermic process? There will be release of energy that we have discussed, right? There will be release of energy. Release of energy. Okay, and this exothermic process is actually spontaneous process. This is your spontaneous process or natural process. So Q greater than 0 है ना, तो यहाँ से Q greater than 0 कब मिलेगा? So it means that MA plus MB, that should be greater than equals to that should be greater than MC plus MD. In this expression, from this expression, we can see that Q greater than 0 means this factor greater than 0, which means that rest mass of the reactant should be greater than product. So what is happening actually in exothermic process? Some of the mass of the reactant actually converting to kinetic energy of the product, है ना? तो यहाँ पे देखो मास लॉस हो रहा है ना, इनिशियल इतना मास था, है ना, और फाइनल प्रोडक्ट में मास, रिएक्टेंट का मास प्रोडक्ट से ज्यादा है. इसका मतलब क्या है? देयर इज अ लॉस ऑफ मास इन दैट प्रोसेस, एंड दैट लॉस इज हैपनिंग बिकॉज सम ऑफ द मास इज कन्वर्टिंग टू एनर्जी, and that is kinetic energy. Okay, and second process you have a Q less than 0, and this is called endothermic process. That is called endothermic process. Endothermic process is actually not spontaneous process, है ना, ये naturally होते नहीं है ना, इसको हम कराते हैं. This process is natural process or spontaneous process. This is not spontaneous process. Okay, so if you see again in terms of mass, है ना, Q less than 0, इसका मतलब क्या है कि mass of the nuclear mass of a reactant is less than mass of the product. So there is a gain in the mass, है ना. यहाँ पे देखो process में क्या हो रहा है? There is a gain in the mass because mass of the product is greater than reactant in endothermic process, है ना. ठीक है ना. So what is the meaning of that? To make this process, you have to supply some energy. To make this process, you have to supply some energy in the form of kinetic energy of incident particle. Suppose A is your incident particle. A is your incident particle that is bombarded, and B is A is incident particle and B is your target. Okay, so to make that endothermic process, you have to supply some energy in the form of kinetic energy of incident particle. ठीक है ना? Because that energy is actually converting to mass of the product. Okay, so this is non-natural process, or this is not a spontaneous process. You have to supply some energy to make this process, but this process, exothermic process, is spontaneous process. There's no need of energy to make this process. Okay, so tomorrow we'll continue this. Okay, hopefully 2 more classes are needed.